Hello students, welcome. Welcome to KIT Classroom. Today we are going to study one of the most important topic of mathematics, that is trigonometry. This topic, I don't know why students generally say, or some of the teachers also say, that this topic is very tough. But I personally feel this topic is one of the easiest topic of your course. So let us try to see what is a preparatory requirement. Therefore, this lecture we are calling as a preparatory lecture. So in this lecture, what we shall do is that we will try to prepare ourselves for trigonometry. Entire trigonometry, the entire trigonometry revolves around the right angle triangle. Hoping that you know right angle triangle. So our right angle triangle is on the board, triangle A, B, C, where at 90 degrees, at B we take 90 degrees angle. So in the right angle triangle, angle B is 90. What type of angle will be angle A and angle C? So here first we shall try to understand what are the elements of the triangle. So whatever we are going to study is related to right angle triangle. So whatever information we are going to write on the board, that will be strictly related to our right angle triangle, because for the trigonometry we must know right angle triangle in detail. So the first thing is that what are the elements of right angle triangle? So the elements of the right angle triangle are three angles and three sides. In the second part, we shall study what is the relation between this angle and the sides. Second, relation between angle and sides. So when we talk about the right angle, the side opposite to 90 degrees is always called hypotenuse. So now we shall take each and every angle and try to study the relation of the angle with the sides of the triangle. For example, first we shall take angle A, and now we shall take the sides. So the sides of the triangle are side AB, side BC, side AC. Similarly, we shall try to see the relation between angle C and the sides. So we have here side AB, side BC and side AC. Now, so angle A relation with the three sides, angle C relation with the three sides, angle B relation with the three sides, we shall see it sometimes later. So in this, what is the relation between angle A and side AB? You will note that it is adjacent side. Then angle A and BC, it is opposite side, whereas angle A and side AC, if you note, it is adjacent, but in a right angle triangle, the side opposite to 90 degrees is always hypotenuse. Therefore, this side we shall say that it is compulsorily hypotenuse. In the same way, we will try to study the relation between angle C and the three sides. So here again angle C, here it is side AB, it is opposite relation. So side AB is opposite to angle C. Then for angle C, side BC is adjacent side and side AC is compulsorily hypotenuse. Therefore, we write here hypotenuse. Now note here very carefully that what is the relation between angle A and the sides, angle C and the sides. You will note that for angle A and for angle C, the sides are either opposite or adjacent or hypotenuse. These three things are very much important. For the angles of the triangle, not the right angle triangle, the other two angles, we can note here that the relation between the sides and the angle is either the side is opposite to the angle, or it is adjacent to the angle, or it is a hypotenuse. Now from here we will go to the next part. So as far as relation is concerned, so what type of relations we get? So relation between angle and side, the relations are either opposite, adjacent or hypotenuse. Now we will have one of the important understanding, that is the third point. Side or sides are numbers. Very important understanding this is. Now look here. Whenever you draw any type of triangle, this side are going to have some length. That is, either it will be suppose 5 centimeter, this will be somewhat 7 centimeter, and this may be something, we will take some correct figure. I think we will take this as 3, this as 4, then this will be 5, satisfying the Pythagoras triplet. So in this, if the side is 3, 4 and 5, these sides will have certain numbers followed by certain units of it. So here we say that the sides are numbers. That means whenever there is a side, it will have a number with it. So we say sides are number. If we take the same example, so here in relation, again we will go to the relationship of any one angle, that is angle C. For angle C, side AB is of length 4 centimeter, side BC is of length 3 centimeter, and the hypotenuse AC is of length 5. Now relationship between angle C and AB is, this is opposite, this is adjacent, and this is hypotenuse. So what is the opposite side? So opposite side is nothing but it is some number. Then adjacent side is also a number and hypotenuse is also a number. So whenever we talk about sides, at the back you must understand side means certain numbers are there. So this is the third point. Now we shall go to the fourth point. We can cover it here. That is general property of triangle. So one of the general property which we need here is sum of all angles of a triangle is 180 degrees. Now suppose if one of the angle, for example, let me will go for A. For example, A is taken as theta. So what shall be the measure of angle C? So that will work out. So as per this general property, that is sum of all angles is 180. So here we can work out that angle A plus angle B plus angle C is equal to 180 degrees. Angle A, we have taken it as theta plus angle B being a right angle is 90 degrees plus angle C we are interested in finding out is equal to 180. Now on transferring theta and 90 to the right hand side, you will get angle C is equal to 180 minus 90 degrees minus this theta degrees or theta. Further calculating it, angle C is equal to 90 degrees minus theta. So your angle C is 90 minus theta. So here you can note that if angle C is 90 minus theta and angle B is 90, so definitely this angle theta and 90 minus theta must be less than 90. Therefore, these angles, this theta or angle A is an acute angle, and also this angle C or 90 minus theta is also an acute angle. So at the end of this part, you must remember that in a right angle triangle, one angle is 90 degrees, whereas the remaining two angles are acute angles. And angle C, which is an acute angle, or we have studied in the just few minutes back that the relation between the angle and side. So here you must now specify that this angle is compulsorily acute angle. It is compulsorily acute angle. So in short, what we have to do is that what is the relation between the acute angle and sides of a right angle triangle? See, initially only we have focused that whatever discussion we are going to do is always in relation to right angle triangle as far as trigonometry is concerned. So from this, now we will sum up this. So on having the sum, so acute angle and its relation with the sides. So what is our relation? O, A, H. What is O, A, H? So these are numbers. Remember this, because we have done it right now, that these are numbers. Now the further part, if you take, just take these numbers O, A, H, which will be opposite side of one of the acute angle, adjacent side of one of the acute angle, and hypotenuse of the right angle triangle. So when we take these numbers, you take this number and try to prepare a fraction. So if you try to prepare fractions, that is writing in numerator denominator form, so we can take O by H, then you can take A by H, and then we can take O by A. You can make this fraction by using any of the two numbers. Try to make as much fraction as possible. I will write the possible fraction on the board. 3 are written and 3 are here. So once these fractions are ready, numerator and denominator, if these are written in this form, O as to H, if the fraction are written in this form, then we say it is a ratio. Now instead of saying fractions, we will say we have 1, 2, 3, 4, 5, 6 ratios. So we have 6 ratios which are prepared from the numbers, that is the sides of the right angle triangle, when we are relating our side to the acute angle of the, when we are relating the sides to the acute angle of the triangle. So now we are having 6 ratios. Once we get the ratio, now we will try to give them certain names. So naming the ratio, see, it is just like we take birth first and then we are given certain names. Can you understand this? Once we take birth, we are a small baby. In due course, we are given certain name. and then people recognize us with that name. In the same way, we have now 6 ratios and now we will name them. If the ratio is opposite upon hypotenuse, this ratio is called as sine ratio. If it is adjacent upon hypotenuse, it is called as cosine ratio. If it is opposite upon adjacent, it is called as tangent ratio. Then if it is hypotenuse upon opposite, it is called as cosecant. If it is hypotenuse upon adjacent, it is secant, and if it is adjacent upon hypotenuse, it is called as cotangent. On observing, you will note that your O upon H, which is cosine, the ratio in front of it is exactly the inverse of it, that is hypotenuse upon opposite, which is called as cosecant. Similarly, cosine, which is adjacent upon hypotenuse, the inverse is hypotenuse upon adjacent called as secant, and then O upon A, that is opposite upon adjacent, is called as tangent, and inverting it, the inverse is adjacent upon opposite, which is cotangent. Once we get these names, then in the long run, instead of calling it sine ratio, cosine ratio, tangent ratio, cosecant ratio, secant ratio, cotangent ratio, we give some short names. So the short name for sine is sine itself, which is written as sine, S-I-N. For cosine, the short name is cos. For tangent, the short name is T-A-N, tan. For cosecant, it is cos. For secant, sec. And for cotangent, the short name is cot. So try to remember this name. What is sine? So whenever we say sine, so automatically in front of sine the ratio will come as O by H, that is opposite upon hypotenuse. When we say cos, it is adjacent upon hypotenuse. For tan, O by A. For cosec, H by O. For sec, H by A, and for cot, A by O. So these are the ratios, and here this starts your important part of trigonometry. 6 ratios of trigonometry. How we get them? Just nothing. If you are confirmed that the sides are numbered, take these numbers, try to prepare fractions. If the fractions are written in this dot form, we say it is ratio, and then try to prepare as number of ratios as much as possible. You will find that you are able to prepare 6 ratios. If these 6 ratios are arranged in proper order, you will find that in front of sine ratio, we write the inverse of it. In front of cosec, we write the inverse, and in front of tangent, we write its inverse. So in this way, now we get 6 ratios. So now we shall go for the next part. Okay, we'll give up this everything. This is not needed. This is also not needed. This is not needed. This is also not needed. Okay. So now we have 6 ratios right here. Sine ratio, which is nothing but adjacent upon hypotenuse. Cos ratio, this is opposite. This is adjacent upon hypotenuse, and this is your tan ratio, which is opposite upon adjacent. Then we have here cosec ratio, which is hypotenuse upon opposite side. Sec ratio, which is hypotenuse upon adjacent side, and cot ratio, which is adjacent upon opposite side. Now, when we relate sine, now these ratios are related to certain angles. For example, if you take sine C, so for angle C, and it is necessary that this angle C must be compulsory acute angle. Now look here, in the initial stages, when we are having the preparatory, you must have certain concept very clear. So the angle here is C. In further cases, you may get an angle which is 120, 100, something like this. So that will be a different case. Overall, when we come down, we again come down to see that it is an acute angle. So for angle C, it is an acute angle. So I'll just rub it out. So here angle C is an acute angle. For the sine ratio, when we compare, sine is opposite upon hypotenuse. So for your angle C, what is opposite side? AB, and adjacent is AC. So here we have AB upon AC. Similarly, taking the cos ratio of angle C, it is adjacent upon hypotenuse. So for angle C, BC is the adjacent and hypotenuse compulsory AC. So it is BC upon AC. And the third ratio, tan C, opposite upon adjacent. So for tan C, it is opposite AB upon adjacent BC. So AB upon BC. Now try to understand again sine C. Sine ratio means opposite upon hypotenuse. This opposite side and hypotenuse are related to certain angle. Here we are taking the acute angle C. So sine C means two angles C, what is the opposite side and what is the hypotenuse. Therefore sine C is taken as AB upon AC. Just check it out once more. For this angle C, your opposite side is AB and hypotenuse is AC. So AB upon AC. Similarly, for cos C, we are having adjacent upon hypotenuse. So your C is here. This is your adjacent side BC. This is your hypotenuse AC. So we'll get BC upon AC. And similarly, for tan, it is opposite upon adjacent, and we are interested in angle C, that is tan C. So tan C opposite is AB, adjacent is BC. So here we have tan C is equal to AB upon AC. In the same way, go for the other 6 ratios. Cosec C is equal to hypotenuse upon adjacent. So for C, hypotenuse compulsory AC and opposite AB. For sec C, it is hypotenuse upon adjacent. So hypotenuse compulsory AC, and for angle C, the adjacent side is BC. And then cot C, it is adjacent upon opposite side. So for C, adjacent is BC, opposite is AB. Cot C adjacent BC, yeah, BC upon AB. So once you get these ratios, then we will compare this ratio with the ratios of the other acute angle, that is acute angle A. Now we will have slight change here. Try to understand that now very carefully. In place of C, which is an acute angle, we can write its measure, which is 90 minus theta. So now I'll rub this and I'll write here sine in bracket 90 minus theta. Similarly, we can write here for cos also, cos 90 minus theta, and for tan it is again tan 90 minus theta. In the same way, for cosec C, I'll write it fast, it is cosec, this I'll write here sec, and then cot, and in place of C we are going to write the measure of the angle 90 minus theta, 90 minus theta, and 90 minus theta. See, now you try to just remember this thing, how we are replacing the angle with its measure. So sine 90 minus theta, previously we have written it is sine C. Now what is C? Is an acute angle. So 90 minus theta is also an acute angle, and we get the 6 different ratio. So boys, today we will stop our lecture here. Tomorrow we shall continue with some backflash and then take this to the further part of your preparatory lecture. So our preparatory lecture will go for another 2 days, including today it will be 3 days. So just attend the lectures. Thank you very much. Bye. तेरा बोलो।